Now, in the previous video, we talked about how the derivative of e to the x is just e to the x. So e to the x is one of those special functions that can say, I'm my own derivative. Now, we also talked about how the derivative of natural log of x, or ln of x, is 1 over x. Okay, so let's use these two facts to find derivatives of more complicated functions. So notice in part A, we have not ln of x, but ln of x to the 7th power. So how do we take the derivative in that case? So let's go through each of these one by one. So part A, how do we take the derivative of this? Well, what we're going to do is rewrite this as 7 times natural log of x. So what I've used here is the power property of logarithms that tells us that we can take this 7 and bring it out front. Okay, now how do we take the derivative of 7 times ln of x? Well, this is just a constant. And remember, the derivative of a constant times a function is just the constant times the derivative of the function. So the derivative of 7 times ln of x is just going to be 7 times the derivative of ln of x, which is just 1 over x. So our answer is just 7 times 1 over x, or 7 over x. Okay, so notice we had to use a property of logarithms to simplify this expression or rewrite this expression ahead of time before we took the derivative. Now in part B, we have 13 times e to the x. So how do we take the derivative? Well, notice, again, this is just a constant times a function. So the way we take the derivative is just the constant, 13, times the derivative of the function, but the derivative of e to the x is just e to the x. So here's another function which can say, I'm my own derivative, 13 times e to the x. Okay, well, let's look at the next one. This one is not a polynomial because we have this ln of x and e to the x, but it starts off looking like a polynomial. So how do we take the derivative? Well, we're going to take the derivative by doing f prime of x is 8x to the 7th power minus 14x. Now, what about for 4 times ln of x? How do we take the derivative there? Well, we just do 4 times the derivative of ln of x, which is just 1 over x. Now, minus the derivative of 10 times e to the x is just going to be 10 times the derivative of e to the x, which is just e to the x. And the derivative of 21 is just 0. Now, we can rewrite this as 8x to the 7th minus 14x plus 4 over x minus 10 times e to the x. And that's our answer. Okay, moving on, part D. How do we take the derivative of ln of 5 over x cubed? Well, what we're going to do here is use the quotient property of logarithms, which tells us that the way you can simplify natural log of a quotient is it's equal to the difference of the logarithms, right? Log of a quotient is equal to a difference of logarithms. Okay, log of a product would equal a sum of logarithms. That's the product property of logarithms. The quotient property says log of a quotient is equal to a difference of logarithms. Now, we're going to rewrite natural log of x cubed as 3 times natural log of x. Now, how do we take the derivative of this? Well, what is the derivative of natural log of 5? Is it just 1 over 5? No. Okay, ln of 5 is just a constant, and the derivative of a constant is just 0. Okay, it's kind of like if you have f of x equals x to the 4th power. Well, we know the derivative of x to the 4th, right? F prime of x would be 4x cubed. But what if we had 2 to the 4th power? What's the derivative of 2 to the 4th power? Is it 4 times 2 cubed? No, right? That power rule only works if you have x, right? Your variable x to some power. It doesn't work if you have a constant to a power. In fact, 2 to the 4th is just 16, and the derivative of 16 is just 0. Right? So the power rule only works if you have x to the 4th power. Same thing for natural log. The derivative of natural log of x is 1 over x, but the derivative of natural log of 5, that's not 1 over 5, it's just 0. Okay, again, ln of 5 is a decimal. Just type it into your calculator, ln of 5, you just get a constant. It's some crazy decimal. Now, what about the derivative of 3 times ln of x? Well, it's just 3 times the derivative of ln of x, which is just 1 over x. So our final answer is just minus 3 over x. Okay, and last of all, part E, how do we take the derivative of 2 times ln of 3x? Well, again, we're going to use a property of logarithms to simplify this. Ln of a product is equal to a sum of logarithms, right? So ln of 3 times x is the same thing as ln of 3 plus ln of x. Now, if I write it like this, I'm going to get it wrong because it's not just 2 times ln of 3 and then plus ln of x. It's 2 times the whole thing, right? But ln of 3x is the same thing as ln of 3 plus ln of x. Now, let's distribute the 2 and write this as 2 times ln of 3 plus 2 times ln of x. Now, we could take the 2 and bring it up here and write this as ln of x squared. Okay, but there's no point in doing that because we already have it in the form where we know how to take the derivative. So again, we haven't done a derivative just yet. We've just rewritten our original function like this. Okay, so now what is f prime of x? Well, again, the derivative of 2 times ln of 3, that's just 0 because this is just a constant. Okay, now what about 2 times ln of x? Well, that's just going to be 2 times the derivative of ln of x, which is 1 over x. So our final answer is just 2 over x. Okay, now what about functions like these? Well, in this module, we're not going to look at functions like these. These are more complicated functions. We're actually going to look at these in the next module when we learn about the chain rule and the product rule and the quotient rule for derivatives. So in part A, by the way, we're not allowed to bring this 2 out front here because that only works if it were the whole expression inside here squared. Then we could bring the 2 out front, but we have ln of x squared, so we can't bring that out front. Also, what we can't do, this is not the same thing as ln of x squared plus ln of 3x plus ln of 7, right? Logarithms don't work that way, right? You can't just distribute the logarithm like this, right? That doesn't work that way. Log of a sum is not equal to a sum of logarithms. That doesn't work. So how could we take the derivative of this? Well, we'd have to use something called the chain rule, which we'll learn about in the next module. Same thing right here. We have a product of two things. We can't just take the derivative by doing the derivative of this times the derivative of this. And even if we could do that, how do we take the derivative of e to the 5x squared plus 1? So we're going to learn about the chain rule and the product rule and the quotient rule for derivatives in the next module. So we'll have to hold off on these until then. And finally, this is not something you'll need to know for this class, but it might be something that you're just curious about. If b is any positive number, then what is the derivative of b to the x? So for example, 5 to the x. What's the derivative of 5 to the x power? Right? So in other words, if f of x is 5 to the x, what is f prime of x? Well, you can't just take the x out front and then lower this and make this x minus 1. In other words, the answer is not going to be x times 5 to the x minus 1. Because in order to use the power rule, the base is what needs to be the variable. But our base here is a constant. It's our variable that's in the exponent. So if you had like f of x equals x to the 5th, yeah, the derivative there, f prime of x, is going to be 5x to the 4th, right? We can use the power rule. But you're not allowed to use the power rule here, right? This is a polynomial. You can take the derivative like this. This is not a polynomial. This is an exponential function. How do you take the derivative of something like this? Well, it turns out the derivative of b to the x is b to the x times ln of b. So the derivative of 5 to the x would be 5 to the x times ln of 5. Now, ln of 5 is just a decimal here. So qualitatively speaking, it's kind of like the derivative of 5 to the x is just 5 to the x, but it's actually 5 to the x times this little fudge factor here, ln of 5. Okay, and ln of 5 is just a crazy decimal. Or suppose you had f of x equals, I don't know, 7 to the x. Well, the derivative of 7 to the x would be 7 to the x times ln of 7, that decimal ln of 7. Now, finally, what if you had f of x equals e to the x? Okay, then what does this say here? The derivative of e to the x. Well, don't we know the derivative of e to the x is just e to the x? Well, what would this rule say? This rule says the derivative of e to the x is e to the x times ln of e. Okay, so f prime of x should be e to the x times ln of e, but ln of e is not a crazy decimal. In fact, ln of e is just 1. So the derivative, so this simplifies to just be e to the x. The derivative of e to the x is e to the x. So in other words, that formula that says the derivative of e to the x is e to the x, that's actually a special case of this more general formula that works for any b. But again, you're not going to need to know how to take the derivative of 5 to the x or 7 to the x, even though I just showed you how to do it. You're just going to need to know that the derivative of e to the x is e to the x. But that really is a special case of this more general formula. Now, you might also wonder, what's the derivative of not like natural log of x, but log base 2 of x, let's say, or log base 7 of x? Okay, so I'm going to rewrite the formula right here. How could we take the derivative of, let's say, log base 2 of x? Okay, well, according to this rule here, this says the derivative of log base 2 of x is going to be 1 over x times ln of 2, right? So our b here is just 2. This will be 1 over x times ln of 2. Now notice that qualitatively speaking, this is kind of like just 1 over x, but you're multiplying by this fudge factor here. Ln of 2 is just some crazy decimal. It's kind of like the derivative of log base 2 of x is just 1 over x, but it's not just 1 over x, it's 1 over x times ln of 2. Okay, similarly, what's the derivative of log base 7 of x? Well, again, qualitatively speaking, the derivative is going to kind of just like be 1 over x, but it's actually 1 over x times ln of 7. And ln of 7 is this little fudge factor. It's a decimal here. Okay, so this rule works for any b. Now, what would the rule say for something like this? F of x equals log base e of x. Well, remember, log base e of x is the same thing as natural log of x, and we already know the derivative of natural log of x is 1 over x. So our answer should be 1 over x. But what does this formula say the answer is? Okay, if we use this formula, if we let b be e here, so instead of letting b be 2 or b be 7 like we did here, what if we let b be e? Well, the formula says the answer should be 1 over x times ln of e. But again, ln of e is just 1. So this is just 1 over x, just like we would expect it to be, right? The derivative of log base e of x, or natural log of x, is 1 over x. So again, these formulas are nice, and they're nice to know, and they're more general formulas. But really, you're going to only need to know the special case of these formulas when b is e. You're just going to need to know that the derivative of e to the x is e to the x. And the derivative of natural log of x, right, log base e of x, is 1 over x. Okay, because in those cases, the ln of b part, which would be ln of e, just simplifies to be 1. And so that part just gets knocked off in these formulas when we're using b equals e.